Good morning, students. Myself, Dr. Intes Karta, Associate Professor, Department of Information Technology. Today, we begin the course Fundamentals of Artificial Intelligence, which is a minor course designed for S6 students to give you a strong foundation in AI concepts, irrespective of your core branch. We will first discuss the course outcomes. There are 5 course outcomes. The first one is understanding AI history, foundation, and scope. So understand how artificial intelligence evolved from early ideas to modern systems. We will discuss the foundations of AI, understand the scope of AI in real world applications, and these outcomes help the students develop a clear conceptual background of what AI can and cannot do. Second course outcome is applying search algorithms for problem solving. Students will be able to understand different types of search techniques used in AI. We will discuss the use of suitable algorithms to solve classical AI problems. This outcome focuses on developing logical thinking and problem solving skills. And the third course outcome is knowledge representation, inference, and reasoning. So students will be able to understand how knowledge is represented inside an AI system. And we will discuss different methods like proposition logic, predicate logic, and understand inference mechanism to derive a new knowledge and analyze how AI system reason and make decisions. And this outcome explains how a machine store information or knowledge and draw conclusion like human. And the fourth course outcome is AI planning techniques and algorithms. So students will be able to understand the concepts of planning in AI, analyze classical planning techniques, understand hierarchical planning approaches, and learn how AI system plan a sequence of actions to achieve the goal. So this outcome helps the students to understand decision making and goal oriented behavior in AI. And the fifth course outcome is learning techniques and intelligence system. Students will be able to understand different machine learning techniques, including decision trees, explanation based learning, reinforcement learning, and also gain basic knowledge of expert system and genetic algorithm. So students will be able to analyze how AI system learn from data and experience. So this outcome introduces students to how machines improve performance over time. Next, we will discuss about textbooks. So here we are following two textbooks. The first one is Stuart J. Russell and Peter Norvin's Artificial Intelligence, a Modern Approach. That is the first textbook we are following. And the second one is Elaine Rich and Kevin Knight, Artificial Intelligence. These are the two textbooks we are following. And this is our week one topics, concepts of AI, history, overview of AI application areas, intelligent agents, and structure of agents. We can see the definition of AI. Artificial intelligence is a wide-ranging branch of computer science concerned with building smart machines capable of performing tasks that typically require human intelligence. Here we can see the word building smart machines. What is smart machines? So smart machines that can learn, decide, and predict. So for example, face unlock on phones, Google Maps suggesting routes, Netflix representation, smart detection in email. So according to the father of artificial intelligence, John McCarthy, he actually coined the term artificial intelligence in 1956. That's why he is called the father of AI. According to his words, artificial intelligence is the science and engineering of making intelligent machines, especially intelligent computer programs. That means intelligent behavior shown by machines using computer programs. So there are 4 approaches to define AI. These definitions are grouped into 4 categories based on the 2 questions. There are 2 questions. The first one is, should machines think or act? That is the first question. And the second one is, Should they behave like human or rationally? These are the two questions. We will see the definitions. The definitions on the top are concerned with thought process and reasoning, whereas the one on the bottom addresses behavior. The definition on the left measure success in terms of fidelity to human performance, whereas the one on the right measure against on ideal performance measure called rationally. We will see one by one. The first one is thinking humanly. Thinking humanly means make machines think like humans think. Here the goal is to copy the human thought process. So this approach focuses on simulating human thought process, how the human thinks. The same way we have to make the machine that machine should think. It tries to understand how human reason, learn, remember, and solve problems. So knowledge from psychology, neuroscience, and cognitive science are used here. The goal is to model the internal mental process of the human. For example, we can say that a program that solves programs step by step like a human. So here we have to simulate human memory, perception, and learning. Next one is think rationally, thinking rationally, making machines that think logically and correctly. So this approach is based on logic and mathematics. So it uses formal logic, that means proposition logic and predicate logic, that we will discuss it later. The goal is to derive correct conclusion from the given facts. So there are some facts are given, and from the facts we have to derive the correct conclusion. For example, expert system, automated theorem provers, logic-based AI system are the examples. And the next one is acting humanly. That is a Turing test approach. Acting humanly refers to creating machines that behave like human. So the Turing test that is actually introduced by Alan Turing. So if according to this Turing test, if a machine can imitate human behavior such that human cannot distinguish it from another human, it is considered intelligent. That is a Turing test. That means if a machine can imitate human behavior such that the human cannot distinguish it from another human, it is considered intelligent. Focus is on observer behavior, not internal reasoning. For example, we can say that chatbot, virtual assistant, humanoid robots are the examples. And next one is acting rationally. That is rational agent approach. Acting rationally means designing agents that take the best possible action to achieve a goal. This approach is based on the concept of rational agent. So rational agent means that perceives its environment using sensors. That means it collects information from the environment using the sensors and act using actuators and chooses the action that maximizes the performance measure. It does not try to imitate human but focus on optimal behavior. That is acting rationally. So for example, we can say that self-driving car, chess playing programs, autonomous robots, intelligent recommendation systems. So we can say that acting rationally is the most widely accepted definition of AI today. Next, we will discuss the history of AI. We will start from foundations before 1950. That period we can call it as pre-AI era. In the year 1943, Warren M. McLoach and Waterpix proposed a model of artificial neurons. The human brain consists of neurons, and this McLoach and Pitts showed that a neuron can be modeled using logic and mathematics. So a neuron can perform basic operations like a and or not operations. means logical operations. This proved that thinking can be represented computationally. In the year 1949, Donald Hebb demonstrated an updating rule for modifying the connection strength between neurons. It is called Hebbian learning. So according to the Hebbian learning, neurons that fire together wire together. That means if two neurons are activated at the same time, the connection between them becomes stronger. So this explains learning through experience. For example, when you repeatedly practicing a skill, the brain strengthens certain neural connections. Similarly, AI system can learn by adjusting weights. So the Alan Turing asked the famous question, can machine think? He proposed the Turing test to measure the machine intelligence. In 1950, he proposed this Turing test. Can machine think? Next is birth of artificial intelligence, 1955 to 1956. In the year 1955, this period actually marks the official beginning of artificial intelligence as a scientific and academic discipline. During this year, AI moved from theoretical idea to the actual working programs, and the term artificial intelligence was formally introduced. In the year 1955, Alan Newell and Herbert S. Simon created the first artificial intelligence program, which was named as Logic Theorist. This program had proved 38 out of 52 mathematical theorems and finally new and more elegant proofs for some theorems. So the logic theorist was designed to mimic human problem solving skill. It focused on proving mathematical theorems automatically. The logic theorist is considered the first AI program. So John McCarthy officially coined the term artificial intelligence in the year 1956 in a Dartmouth conference that is considered as the birthplace of AI. AI was recognized as a separate academic field for the first time. Next is the period 1952 to 1969. So this period is known as early enthusiasm, great expectations phase of artificial intelligence. During this time, AI researchers achieved several impressive but limited successes. So before 1950, computers could only calculate numbers. So during this period, AI showed small intelligent behavior. So according to John McCarthy, Lukma no hands. That means AI shows small intelligent behavior. We have already seen the first AI program, that is Logic Theorist, that is developed in 1956, that proved math theorems. Next is General Problem Solver, that is developed by Newell and Simon, that is based on physical symbol system hypothesis. So GPS, the main idea is break the problems into sub-goals. So that means solve one sub-goal at a time, similar to human thinking. So according to Newell and Simon, any system that shows intelligence works by manipulating symbols. Symbols means something that represent something else. For example, we can say that numbers, words, images, and data. So any system that shows intelligence works by manipulating these. The next is checkers. That is, AI learns to play games. Program learned from this checkers program that is developed by Arthur Samuel. He wrote a program to play checkers. So the program learned from experience, improved by playing itself, and also eventually beat its creator. So this proved computers can learn, not just follow the rules. In 1958, John McCarthy created Lisp, a programming language specially for AI. So Lisp was the most important AI language for 30 years. Then McCarthy proposed something called advice taker. Advice taker, that is the foundation of AI system. Think of it as an intelligent assistant. So according to McCarthy, the advice taker means we can consider the system as an intelligent assistant. It could store knowledge, reason using logic, and accept new information and plan actions. For example, we can say that airport, if you tell to the machine, airport is far, then it can plan to go by car. Many modern AI ideas came from this concept. To make AI easier, researchers actually created microworlds, that is a limited environment. So microworlds are small and controlled environment. So solving calculus, solving word problems, IQ style puzzles. So these programs looked intelligent, but only inside within a small world, that is micro world. The most famous micro world was block world. So blocks world means blocks on a table. There is a blocks on a table, a robotic hand is there, and English commands. The robot hand can pick one block at a time and move it and place it somewhere else. Then next is SHRDLU, that is developed in 1972. It is actually Natural Language Understanding Program. Then early neural networks. Some researchers said instead of logic, let us copy the brain. So they developed perceptron. So these models could learn patterns. So this is the starting point of today's deep learning. All these systems worked well only in small environments. So they failed in real world, complex situations, common sense reason. So this lead to disappointment, which later caused the AI winter. Next period is 1966 to 1973. Now we are going to see a phase where AI researchers were forced to face reality. A dose of reality means AI researchers realized that intelligence is much harder than they initially thought. Early AI worked well only in simple problems. When they tried real world problems, system failed. So according to Herbert Simon, there are now machines that think, learn and create, and very soon their abilities will match the human mind. But these predictions did come true, but not in 10 years. They took nearly 40 years. So the major problem was no real understanding. The most early AI programs did not understand their subject. They used syntactic manipulation, that means manipulating symbols, following rules, and then without understanding the meaning. So that means without understanding meaning, what we have written, just follow the rules. So the machine translation failure. So the computer translated word by word, but it had no background knowledge, no understanding of meaning. That is, this really failed in real language. In 1966, a government committee evaluated machine translation. They concluded no successful general machine translation exists. So as a result of this, all US government funding was stopped. This is ALPSC report. So this was a major shock to AI research. Most AI problems actually use search. Search means they tried one solution, then another, then another. So this actually worked in micro worlds, that means small environment. But real world problems have millions of possibilities. So this leads to something called computational complexity. That was the second major problem, that is computational complexity. Then early AI also tried machine evolution, now called genetic algorithms. The idea was make small random changes, keep useful changes. In theory, it sounded perfect, but in practice, thousands of CPU hours is needed, and almost there is no useful result found. It is because of computers were too weak at that time and representations were poor. In 1973, the Lighthill report criticized AI research in UK. The report said AI cannot scale to real-world problems due to combinatorial explosion. As a result, the British government stopped AI funding except in two universities. This further slowed AI research. The third major problem is limits of perceptron. But interestingly, the backpropagation was discovered in 1969, but it was ignored at that time. It became popular only in the 1980s. Next period is 1969 to 1979, knowledge-based systems. So in the first decades of AI, that means 1950s to 1960s, problem solving looked like just use general purpose search. Break the problem into small reasoning steps. Try all possible combinations. These approaches are called weak methods. They do not scale to complex real world problems. That means there is no domain knowledge. So it works only for small problems. Then from 1969 to 1979, AI researchers changed their thinking. To solve hard problems, you must almost know the answer already. So that means use domain specific knowledge and take larger reasoning steps. And also they focused on narrow expertise. Next, we will see the expert systems. The first knowledge-based expert system was Dendral, that was used to identify the molecular structure of a chemical component. The input was chemical formula and mass spectrometer data. And this followed McCarthy's advice taker idea that we have already seen. It was considered as the first successful knowledge intensive AI system. Initially, the program tried generate all possible molecular structures and predict the spectrum of each and then compare with the real, but completely impractical. That means there are too many possibilities are there. So they discussed with the expert chemist. So chemist said, we don't try everything. We look for patterns in the spectrum. Then patterns indicate non-substructures. So once a substructure is known, the number of possible molecules reduces dramatically. Then next was MySyn. The MySyn is a medical expert system that diagnosed blood infections. It used about 450 rules and it worked better than junior doctors. MySyn actually used certainty factors. So we know medical decisions are uncertain. So MySyn handled this using certainty factors. For example, we can say that if symptom is X, then there is a possibility of 0.7 uh, that the disease is Y. If we have a symptom X, we cannot say that this symptom is for a particular disease. There is a possibility of many diseases actually. Next is AI becomes an industry from 1980 onwards. From the 1980s onwards, something major happened. AI moved from laboratories to companies. That means till 1970s, artificial intelligence was mainly a research topic in universities. From the 1980s, AI moved out of labs and entered companies. The first major success was that proved AI can make money was the expert system called R1. R1 system. Early AI program solved toy problems. So R1 solved a real industrial problem that was used in digital equipment corporation and that saved $40 million per year. And this actually increased trust in AI system. So this made the companies realize AI is useful and profitable. So after R1, many companies started AI departments. Not only in companies, even government invested in AI. The most famous was Japan's project. So Japan announced a 10-year plan to build intelligent computers. They plan to use logic programming, prolonged language. So that is a fifth generation project in 1981. Then US started a project MCC, then UK ALVI program. So AI market grew from millions to billions of dollars. When companies failed to deliver promises, funding stopped. This period is called a AI winter. Next is from 1986 onwards. We already know that neural network existed earlier, but they failed in 1960s because they couldn't learn complex patterns. But in the middle 1980s, neural network came back strongly. The key reason for this is the backpropagation learning algorithm. And this was first discovered in 1969 by Bryson and Ho, and it became popular only in 1980s. So we know that earlier neural networks had only one layer. So the backpropagation allowed multiple hidden layers, error correction, learning complex patterns. So that is why neural networks suddenly become powerful. And in 1986, Rumelhart and McClelland published a famous book, Parallel Distributed Processing. So this book spread neural network idea worldwide and created huge excitement. So these neural network models were called connectionless models. Symbolic AI focused on rules and symbols, while connectionist AI focused on learning from data. So today we understand that both approaches are important and they are complementary. Next is from 1987 onwards. AI adopts the scientific methods. So earlier AI relied heavily on intuitions and small toy problems. But the late 1980s onwards, AI began to follow the scientific methods. AI early isolated itself from other disciplines. Now it integrates ideas from statistics, optimization, control theory, and information theory, and so on. Modern AI research requires rigorous experiments, statistical analysis, and reproducibility using shared data set. For example, in speech recognition, today hidden Markov models dominate because they are mathematically sound and trained on large data sets. So these models are not models of how humans think. They are engineering solutions that work well in practice. So that means there are hypothesis testing, controlled experiments, statistical analysis, and reproducibility is there. Julia Pearl reintroduced probability into AI through Bayesian network, allowing AI system to reason under uncertainty. Next is from 1995 onwards. From 1995 onwards, AI researchers started focusing on Word Agent, a system that can sense, think, decide, and act continuously in an environment. This phase is called the emergence of intelligent agents. One of the most famous complete agent architecture is SOAR, developed by Alan Newell, John Layard, and Paul Rosenblum. So SOAR attempt to model general human problem solving and learning. The internet became the most important environment for the intelligent agents. So AI systems are everywhere online today. And that's why we commonly hear the term bots, chatbot, web crawlers, and recommendation bots, etc. So sensors means camera, microphones, or sonar do not give a perfect information. Therefore, agents must reason and plan under uncertainty using probability and decision theory. So, self-driving car are a perfect example of intelligent agent. Their success comes from combining sensors, control theory, mapping, localization, and planning. So, traditionally, AI system focused on algorithms, but modern AI shows that more data often matters more than a better algorithm. So, the web provides trillions of words and billions of images. So from 2001 onwards, the availability of uh, very large data sets. So that means Yorosky showed that AI can learn word meanings without labeled data using huge text corporation. And in image processing, performance improved dramatically only after using millions of images. And from 2001 onwards, the web provides trillions of words and billions of images. Biology provides data, and these actually fuel modern AI. So the large data sets and learning algorithms reduces the need of hand-coded knowledge, and this helps overcome the knowledge bottleneck. With widespread real-world application, AI entered a new spring, ending the AI winter. Then from 2011 onwards, Uh, in the year 1997, IBM Deep Blue beats World Chess Champion Gary Kasparov and become the first computer to beat a World Chess Champion. Then in the year 2002, for the first time, AI entered the home in the form of Roomba, a vacuum cleaner. And in the year 2006, AI became in the AM came in the business world. Companies like Facebook, Twitter, Netflix also started using AI. And in the year 2011, IBM's Watson won Jeopardy, a quiz show where it had to solve the complex questions as well as riddles. Watson had proved that it could understand natural language and can also solve tricky questions quickly. In the year 2012, Google has launched an Android app feature, Google Now, which was able to provide information to the user as a prediction. In the year 2014, chatbot Eugene Guzman won a competition. In the year 2018, the project debater from IBM debated on complex topics with the two master debaters and also performed extremely well. Next, we will see AI application areas. Where do you see AI in your daily life? Commonly, Google Maps, Instagram, Alexa, Netflix, ChatGPT, online exams, and fraud alerts. So AI is not one technology, it is applied across many domains. AI application areas are domains where artificial intelligence techniques are used to solve real-world problems. So we will see some of the domains. First one is machine learning and data analytics, where AI system learns patterns from data and make predictions and classifications. So, for example, student performance prediction, loan approval in financial institutions, then recommendation systems, Amazon, Netflix, etc. Next application area is natural language processing, NLP, understanding human language, text and speech. Examples chatbot, customer care as a customer care, then Google Translate, email spam filtering. Next application area is computer vision. Example face recognition, medical image diagnosis, that is X-ray and MRI, then traffic monitoring. Next application area is robotics and intelligent automation that combines AI with the physical machines. For example, industrial robots, autonomous vacuum cleaners, delivery robots, etc. Next is expert systems. So expert system means mimics human expert decision making. Example, medical diagnosis system, fault detection system, etc. Next is application is healthcare applications. There, this disease prediction is possible, medical image analysis is possible. We already discussed in computer vision, X-ray and MRI we can analyze. Then drug discovery. Next is finance and banking. There we can use AI for fraud detection, credit scoring, and algorithmic trading. Then next application area is smart systems and IoT. Most commonly used AI, that is smart homes, smart cities, energy optimization, etc.